So the third one here is the sample exercise 10.9, page 409. This is relating volumes of gas and reactions. So the safety airbags in automobiles are inflated by nitrogen gas generated by the rapid decomposition of sodium azide, NaN3, according to the following equation. And they give you the equation. If an airbag has a volume of 36 liters and is to be filled with nitrogen gas at a pressure of 1.15 atmospheres at a temperature of 26 degrees Celsius, how many grams of NaN3 must be decomposed? So, again, I'm going to organize myself first. I've got a volume of 36 liters. I've got a pressure, 1.15 atmospheres, temperature of 26.0 degrees Celsius, which Kelvins comes out to be 299. Okay. And how many grams of NaN3? So we are looking for mass in grams of NaN3, right? So if we look at what we have, volume, pressure, temperature, and a mass, correct? Yeah, good. We also can figure out the molar mass, right? We could figure out the molar mass of well, it depends on, so we've got two things, right? We've got this, which is of nitrogen, and then we've got this thing, which is what we're looking for. So actually, let's hold off on the molar mass for a second, just to make sure. I don't know if we need both of them or just one of them. Okay, so the first thing to realize, though, is all the volume, pressure, and temperature, all three of these things are talking about what substance? Like this is the volume and the pressure and the temp for what? For what? What does it say in the problem? Volume for what? Nitrogen gas. Good. So nitrogen gas right here. So this is all for N2. Okay. So again, watch your labels and the stuff they're talking about. So we can actually take this Pivnert and we can Pivnert it to find the number of moles for nitrogen. Now the question is why do we want to find the number of moles? Any ideas? Plug these in. For my R factor, I'm going to use, I've got atmospheres and liters, so I'm going to use this one. Liters, atmospheres, moles K. So 0.08206. Liters, atmospheres over moles K. And temperature is 299 K. Okay. So I do this, I take this times this divided by that, and I end up with 1.69 moles is the label that's left because atmospheres cancel, liters cancel, K's cancel. So this is moles of This is all for N2, right? So this is moles of N2. We're trying to find grams of NaN3. Any ideas what we can do with the moles of N2?
Maybe like 3N2 underneath the
Yeah, good.
2 NaN3.
Yep. We're going to take the 1.69 moles of N2, and we're going to use our balanced equation, and we are going to convert from moles of N2 into moles of NaN3. And here, we're going to use the coefficients like you were talking about. So in front of N2, there's a 3 on the bottom. In front of NaN3, there's a 2, so there's a 2 on the top. Okay, now we're going to go, we want it in grams of NaN3, so we're going to go from moles of NaN3 to grams of NaN3. The grams of that is 65. Okay, and this kicks us out an answer of 73.2 grams NaN3.